These examples go with Lesson 8.4, Hypothesis Tests for Proportions. Example 1. The Pew Research Company Research Center reported in 2008 that only 15% of 18 to 24-year-olds read a daily newspaper. The publisher of a local newspaper wants to know whether the percentage of newspaper readers among students at a nearby large university differs from the percentage among 18 to 24-year-olds in general. She surveys a simple random sample of 200 students at the university and finds that 40 of them, or 20%, read a newspaper each day. Can she conclude that the proportion of students who read a daily newspaper differs from 0.15? Use the alpha equals 0.05 level of significance. All right, if we move over to the next slide, here's a couple of questions that they want us to answer, and I've already moved over some of the information. Now we'll just put our alpha level in here. Okay, part A is asking us to state the null and alternate hypotheses. The null hypothesis has to do with this statement right here. Actually, this is going to be the one for our alternate hypothesis, and then we can get our null hypothesis from that. So, looks like our P0, our proportion, is going to be 0.15 here. So our null hypothesis is going to be, is the proportion really equal to 0.15 as it was reported, versus the alternate hypothesis, is the proportion, now it said differs, it doesn't say greater than, more than, less than, fewer than, it says differs. So this is going to be a not equal to, so is it different from 0.15? That makes this a two-tailed test. Part B is asking to compute the test statistic. This is going to be a z-statistic. And our formula is p hat minus p0 divided by p0 times 1 minus p0 divided by n, and then we are supposed to square root that. All right, so let's plug our numbers in there. Let's see, p hat we're given to be 0.2. P0, we already said that was going to be 0.15. We will divide this by the P0, 0.15, times 1 minus 0.15, divided by n, which they told us was 200, and this gets square rooted. All right, let's put this in the calculator and see what we get. And this looks like it's giving me 1.98. Now, it's actually giving me 1.98029, blah, 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 but since it's a z-score and we're getting ready to use table A2, I'm just going to round it to 2 decimal places here. All right, part C is asking us to compute the p-value. Now, let's take a look at the picture for this. The p-value is going to be the area under my normal curve, and because this is a two-tailed test, we're going to want to know the area of the curve that is more than 1.98, but we also want to know the area of the curve that is less than negative 1.98. And these two areas added together are going to be the p-value. So since table A2 gives me the area to the left, I'm going to use the negative 1.98, and as soon as I know what this area is, I'll automatically know what this one is as well. So let's pull up table A2, and we will be looking for negative 1.98. There's negative 1.9. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, and we get 0.0239. And this one also is 0.0239. So our p-value for part C is going to be 0.0239 plus 0.0239, or times 2, whichever way you want to do it. And that is going to give me 0.0478. So there's our p-value, 0.478. Now, part D, stated conclusion. We've got our p-value, we've got our alpha value. Remember, if we're going to reject the null hypothesis, then our p-value needs to be less than our alpha value here. And so since 0.478 is less than 0.05, we are going to reject our null hypothesis. We're going to reject the null hypothesis because the p-value for our hypothesis test is 0.478, and that is less than our alpha value of 0.05. Example 2, the following output from Minitab presents the results of a hypothesis test. And here we have the printout or the display of the results from that test. And so example 2 is going to be practice reading these results. Okay, part A, what are the null and alternate hypotheses? We can find those right here on line 1, the test of p is equal to 0.6 versus p is less than 0.6. That makes our null hypothesis p is equal to 0.60, and our alternate hypothesis p is less than 0.60. Part B, what is the sample size? Well, that can be conveniently found right here. That's our n. N is equal to 150. Part C, what is the value of p hat? That's going to be this one right here, our sample p. And I'm just going to round this off to, well, I can round it to 2 decimal places because everything else behind it is going to be a bunch of zeros. So we'll just call this 0.48. Part D, what is the value of the test statistic? Well, remember, our test statistic is a z-score or a z-value there. That's going to be found right here. And in our case, z is going to be equal to -3.00. And I'm going to put the 0.00 on here because when we look it up on table A2, we would need to know those 2 decimal places right there. All right, E. Do you reject the null hypothesis at the 0.05 level? Well, our p-value is 0.01. Our p-value can be found right here. This is 0.001, and what we're checking to see is the p-value less than our alpha value? Well, the alpha value is going to be right here, the 0.05. So it looks like we are going to reject the null hypothesis because the p-value in our test here is 0.001, and that is in fact less than the alpha value they gave me of 0.05. We look down here at F, do we reject the null hypothesis at the 0.01 level? Well, again, it looks like we're going to reject the null hypothesis for the same reason. It looks like the p-value for our test here is going to be less than the alpha value that they gave me. So 0.001 is in fact less than 0.01. Example 3. The following display from a TI-84 Plus calculator presents the results of a hypothesis test. Our display is right over here. What are the null and alternate hypotheses? Just like with the Minitab, our hypotheses can be found here. Now, the TI-84 only gives you the alternate hypothesis, and so we'll have to deduce what the null hypothesis is based on our alternate hypothesis. So since our alternate hypothesis is that P is actually greater than 0.75, it looks like our null hypothesis is going to be that P is actually equal to 0.75. B, what is the sample size? Right down here on the last row, that's our N value, 1,225. Part C, what is the value of P hat? This is right here. And I'm just going to round this to 4 decimal places. So that's going to be 0.7559. What is the value of our test statistic? That's our Z value right here. Z is going to be equal to 0. And I'm going to round this to 0.49 because if we were using table A2, we would just need the 2 decimal places there to do that. All right, part E, are we going to reject the null hypothesis at the 0.05 level? Well, we need our p-value in order to figure that one out. And here's our p-value right in the middle. So for part E, it looks like yes. I'm sorry, no, not yes. It looks like we are not going to reject our null hypothesis. And the reason we're not going to reject our null hypothesis is because our p-value is actually greater than our alpha value here. So to not reject the null hypothesis because 0.3162 is actually greater than 0.05. And then question F down here, do we reject the null hypothesis at the 0.01 level? Well, logically we're going to say yes, because we rejected it at the 0.05 level. If we go more precise, we're still going to be rejecting it. But we'll check our p-value, 0.3162, and it is greater than 0.01. So yeah, once again, we're going to reject, or we're not going to reject that null hypothesis. And the reason is because our p-value of 0.3162 is greater than our alpha value of 0.01. I just want to remind you that you can find these p-values over here using the ALEKS calculator. You don't have to do this off the table A2 if you want to. And what you'll do is you'll go over to the ALEKS calculator, and our critical value here is going to be negative 1.98, right? That's our Z value there. And so when you're doing this, remember this is a Z critical value here, so, or a test statistic. So we're going to use the P, Z is less than or equal to. This is going to give us the area under the left tail. And then we would put in the negative 1.98. And then that would give us the area under the left tail. And then remember, example 1 was a two-tailed test. So we would actually have to double this for the area under the positive 1.98. And that would give me the p-value of 0.0477035, blah, 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 blah. So another way you could do this is you could do it in the ALEKS calculator. Okay. Here's example 4. A Gallup poll taken in December 2009 sampled 1,000 adults in the United States. Of these people, 770 said they enjoyed situations in which they competed with other people. Can you conclude that less than 80% of U.S. adults like to compete? Use the critical value method with a significance level alpha equals 0.05. All right, part A is asking us to state the null and the alternate hypotheses. And we can find that right here in this statement where it's asking us to conclude that less than 80% of the U.S. adults like to compete. That is our alternate hypothesis right there. And then we can get the null hypothesis based on what our alternate is here. So we're trying to figure out if the proportion of adults is actually less than 80%, which as a decimal is going to be 0.80. That means our null hypothesis is going to be, is that proportion actually equal to 0.80? Part B, we're going to compute the test statistic. Okay, before we do that, we actually need to know what p hat is. P hat is just the proportion for the sample that I've done. This is the number of people who have the characteristic I'm looking for, in this case, the people who enjoyed situations where they're competing, divided by the number of people in my sample, which in this case is going to be 1,000. So 770 divided by 1,000. And if we put that in the handy dandy calculator, that will give us 0.770, or just plain old 0.77. All right, our test statistic is going to be equal to our p hat, 0.77, minus our p0, which we can find conveniently in the null hypothesis here, divided by our p0 times 1 minus the p0, divided by n, and we want to be sure and square root all of this down here. All right, let's put that in the calculator and see what we come up with. And this is giving me negative 2.37, and then a longer decimal, but I rounded it to 2 decimal places, right, because this is actually a z-score here, well, for table A2. All right, now C is asking us to find the critical value. Now, since we're doing the critical value method, let's take a look at the picture of what's going on. We've got our normal curve here, and our alpha value is 0.05. Now, our test is left-tailed here. So I am trying to figure out what this number is right here so that the area to the left of it is 0.05. Now, I can look this up in table A2. I'd have to be looking in the body of table A2, and I'm looking for an area of 0.0500. And we can pull that up here. So we'd be looking in the body here, or I can pull up table A3, and here's my 0.05, and I can go all the way down to the Z line. 1, 2, 3, 4, and that gives me my critical value right here of 1.645, and I think that one's going to be a little bit quicker there. So let's take this guy off of here, because now we know it's going to be equal to 1.645. And now we have our critical value for part C. And now part D is asking for us to state a conclusion. Well, that all depends. And actually, we want a negative 1.645, don't we? Because that's going to be a left-tailed test back here. All right. We need to figure out where the negative 2.37 lies. Now, we've done some testing like this earlier on. And if the test statistic falls inside the shady region here, remember we reject the null hypothesis, but if it falls over here in the white unshaded region, then we don't reject the null hypothesis. And negative 2.37 is actually smaller than negative 1.645. In fact, it'll be back here somewhere. And so since it falls inside the shaded area, we are going to reject our null hypothesis. And here is our statement for our conclusion. We're going to reject the null hypothesis because our test statistic, negative 2.37, is, that should be a less than, not a greater than sign, but the negative 1.645. Okay, so one more time. We reject the null hypothesis because our test statistic negative 2.37 is less than our critical value negative 1.645. It is in the shaded region, so we do reject.